Hey everyone, it's Miss Bruin back again in the virtual science lab, and I'm here to talk sound waves with you. Hopefully, after this video, you'll understand a whole lot more about how different kinds of sound waves move and how different kinds of sounds create different kinds of sound waves. So, just like water waves, all sound waves are not the same. Some can be powerful enough to break glass, while others have the power to put us to sleep. No matter what kind of sounds you like to listen to, there's no denying that every sound is very different. There are high pitched, squeaky, squealy sounds like the ones that baby otters make. Listen. Then there's really low pitched sounds, like the sound of any villain in any movie. Take a listen to Scar from Lion King.
Promise me you'll never visit that dreadful place.
No problem.
There's a good lad. You run along now and have fun. And remember, it's our little secret.
Now, the difference between sounds that terrify us, like those low pitched villain voices, and sounds that soothe us, lies in their frequency and their amplitude. Now, these are words that we use to describe not just water waves, but we can also use them to describe sound waves. Why don't we take a look at our wave model to explore more about how frequency and amplitude change when the sounds we hear change. So scientists, here we have a model, and our model is going to actually show us what sound waves look like. So you can see there's a speaker on the left side, and there's a green button on that speaker. So that's where the sound is originating from. And I want you to notice what happens when I turn up the volume. I'm going to pull out the graph because I know you can see the waves. They're represented by these dark lines. But if I pull up the graph, you can really see how the waves are traveling out. So if we remember from our water wave investigation, amplitude is the height of a wave from rest. But in sound, the amplitude is the height of the wave. And as you turn up the volume, you'll see that the amplitude increases. So when we talk about sound, amplitude is actually how loud something is. So you can see that those waves get higher and higher as I turn up the amplitude or turn up the volume. I'm going to turn it back down to the middle so that we can now explore frequency. So scientists, I know you already know that frequency is the amount of waves that come in a certain period of time. So we could also think of it like as how fast the waves are coming, right? If there are lots of waves coming in a certain period of time, they're coming very quickly. In sound, it's a little bit different because you can't see sound, right? So when we think about frequency in sound, we may just have to take a listen. So do you hear the tone that's coming out of the speaker right now? It's a pretty low pitch as far as the tone that we're hearing, right? It's not high pitched like a squeal or a squeak. It doesn't really sound like that baby otter at all. As I change the pitch, look at what happens to the frequency of the waves. Watch how fast we see those waves coming. And we actually might want to pull out the graph for this as well. So here we have a low tone, a low-pitched tone. And listen to what happens with the tone. I'm going to up the pitch. I'm going to make it a really high-pitched sound. Watch how it affects the frequency of the waves. So the height of the waves is not being affected at all. But do you see how fast those waves are coming? Now we hear a really high-pitched sound, right? And you can see that the frequency is very high. The waves are coming at a very fast pace. So when we think about sound, frequency actually increases when the pitch gets higher and higher. Okay, scientists, before I go, I have one last challenge for you. We listened to a baby otter earlier. Now I want you to use what you know about frequency to figure out which wave represents the sound we hear coming out of the baby otter. Here, I'll play you the sound again. I'm interested to see what you think. Do you think it's that orange wave at the top? Or do you think it's the bottom wave, the blue wave? So I have a request, a special request. Next time you're listening to your favorite song, or you hear a dog bark, or you hear a fire engine go by, or somebody in your house screams at you, think about the pitch or the frequency of that sound. Think about the volume or the amplitude of that sound, and see if you can picture the sound waves that are created by that sound.